So my name is Deepak. So today I'm going to take that uh, session, and I think Srikanth already told about that. Today I have to discuss that algorithms, no, two algorithms, Floyd-Warshall algorithm and Bellman-Ford algorithm, no.
Yes, sir. Also, that's
Sorry.
Dijkstra's algorithm also.
Yeah, so Digestra, I think that is little bit comparatively easy to these two method algorithms. So that will be discussed in that much more in details in Solve with Instructor session. So I was told to discuss these two algorithms. Okay, and
Okay.
once you understand these two, no, I think that is relatively easy. If you have some problem, then or doubt, you can ask in Solve with Instructor session. That is the only they will talk about only these extra algorithms. Okay.
So that day is clashing with CT 426. Also, solve with instructor. Also, his CT session is also there. Revision session.
So revision session, is it? No. So Thursday are you talking about? No. Thursday we have session from Thursday we have session on Friday.
Thursday we have session 4 to 6 p.m.
It was supposed to 6 to 8 or 7 to 9. No, I think we conduct. I don't know. So a revision
So
session.
same, sir. 24 Thursday 7 to 9 CT same time and mass solve with the same time.
No change.
Not anymore.
No, I think it will be changed. So try to talk to the support team, or maybe I will just convey this one to.
No, it is changed, sir. It has been changed.
Sir,
It's
4
changed.
4
It's
p.m.
4 to 6. Yeah.
4 to 6 p.m. is a math and 7 to 9 is a CT.
Yeah, it's no longer clashing.
Oh, okay, then it is fine, no?
Yeah.
Okay.
It's perfectly fine now. There's no need to change anything.
Yeah. Okay. Yeah. So what's the time now? What's the 4:01? So and I will wait for another 2 to 3 minutes to let them join others. Okay. Let me share the screen.
Sir, I have a doubt in activity 10.9 question number 1, sir.
So I don't like that. That doubts will be cleared by that's other instructors. So I was told to discuss this. I will take after this session, after this one. Okay.
Okay, sir.
Okay, no. Okay. So I will wait for. So I will just talk about this algorithm, and I will try to solve one or two problem for each case. Then I think I will have better understanding. No? So I will not go much more detail in theoretical part because that is already in the lecture. And go and watch, but mostly I will talk about how to find the shortest distance. Okay. Okay, so it's a 403. Should we wait another 2 minutes? This is the general. I mean, how many generally join mathematics?
People join according to their schedules. There's nothing like they must be joining in a minute, or they sometimes join even half an hour later of the session also.
Oh, so mostly the number is around 60 or more than that.
Yes.
Some of are also are in computational thinking.
No, sir.
Yes, some
Sir,
of them
why
are
you are
there.
not coming for
Sir, we
CT,
have
sir?
a session at
Yeah,
7.
I will come now. So I was
Okay.
dealing with something, some personal things. So I was not in Chennai actually. So I had some work.
Okay, sir. Really, we missed you, sir.
Yeah. So I will take now onwards some sessions, in the revision sessions, some of whatever it is possible. I will take the session now.
Thank you, sir.
We are missing you, Deepak.
Yeah. So everyone is there, almost.
Yeah, we need
Yeah,
your help in
nice.
PT actually. We are struggling in week 10
Struggling
and
the
11.
10 and 11 is very tough, sir.
10 and 11. And the syllabus now is no or not? I mean, CT. I think we put announcement.
No, not yet relieved. Yesterday, Joshi was telling it's a surprise. You will get it on 24th morning announcement.
Yeah, nice. To wait for a surprise.
You also don't want to tell?
I don't know actually.
Really?
So come for a session or two and help us revise the concept for the last few weeks.
Yes,
Yeah,
yes,
so
true.
I will take session for that 7, 8, and 9. That's matrix and graph theory, recursion, and DFS. Okay, that session I will take. Maybe
I
some.
rechecked actually when I logged in. I rechecked whether I logged in into CT session or when I saw your name, I thought I logged in maths and then I saw your name there. So quite
So
a
today I'm taking that math session, especially algorithm. Okay, so I think we should start now. So 405, no?
yes,
Yes,
yes.
sir.
Yes,
So we
sir.
can start.
Hello, sir.
Yes, yes, yeah. Just keep
Hello,
going.
sir. Is answer transcript is released for of March 13 exam?
I think you can check through support team. They have not released. I mean, I don't know, Miss.
Sir, it is
Because sir,
released, but
in
it's
my
not
document section
uploaded.
it is showing, but when I click, then it says that URL is not found.
Mm-hmm.
It's
Okay,
showing error, sir.
it
Yes,
is showing error.
Yes,
yes, sir.
sir.
Okay, so did you write any mail to support team?
Yes, sir. I write mail last night. I write the mail. Right
Okay.
now, I didn't get any reply.
Okay, okay. So after this session, I will just convey this one to support team. Okay.
Okay,
Sure.
sir. Thank you, sir.
Chalo. So okay. So today's yeah. So I'm going to start the session. ठीक है ना? चलो.
Yes, sir.
Okay. So see. Generally these algorithms are used to find the distance, and also the distance is not only this is the shortest distance. Okay. I am font size is clear. I mean, are you able to see clearly?
Yes, sir.
Yes, sir.
Sir, I zoom.
What about now?
Now it's
Now it
good.
is fine.
Yes, yes, sir. It's okay.
Is it fine now?
Yes, sir.
Yes.
ठीक है.
Yes.
So see, so generally, how distance when we try to find meaning what with what Means distance we try to find with two vertices, no? So these distance are divided into two categories: the single source to the every vertices, and other one is the pair of vertices. So in single source vertices, what do we do? Like we fix one of the vertices and we try to find the distance from each and from every possible vertices. Okay. Then we have another pair of vertices where we try to find the every pair. Like if there are n vertices, then we should have how many pairs? N into n minus 1 by 2. That is no. That many pairs will be there, no? So that pair of distances we find, and that distance will be the shortest distance when we use these three methods. Okay. So in that, like we have these algorithms that these works to some specific graphs. So if the graph has some negative edges, and if we want to only find with the fixed source vertex to every other vertex, okay, so these two methods are used: Dijkstra algorithm and Bellman-Ford algorithm. And in this, you should not having no negative edges. I mean, so when you use the Dijkstra algorithm, the graph should not have any negative edge weights. Whereas a Bellman-Ford model, so Bellman-Ford model where you can have negative edges, but cycles should not be there. No any negative cycles. And so once you if there is any cycle, and if it is having negative value, once you go for one round, then This Bellman-Ford model is not used. So the Bellman-Ford model is used for all graphs where only you are having negative edges, but there is no negative cycles. So did you understand that negative cycle and negative edge? What did this mean?
No, sir.
Anybody having issue in that? Just let me draw them right somewhere. Can new page. Okay, I can. Why new page is not coming? So
These three algorithms we cannot execute now when negative cycles are there.
yeah, so see, negative cycles means like you have some like point this one. Let me change the color actually. So you are supposed to having like A is there, then you are going to B, and there is some cycle. C is there, so there is some cycle like this. When it is coming like this, this is B, and this is E. Okay, so some negative value is there 5, and overall it is coming how much? Okay, so -2. This having 4 or -3. So this is in, you can see that between vertex B and C there are negative values. So it can have negative weight, but what about this one? What about this one? If you add overall, so once you start from here, B to D, D to E, and E to B, how much it will come once you go for one round?
-1.
One.
So this
One.
is negative cycle. Okay. So this is the difference. Yeah. Okay. So in the this one, no any method. So whatever the method we have, Dijkstra method, Bellman-Ford method, and what is that?
Floyd-Warshall.
Floyd-Warshall.
Floyd-Warshall method. These methods cannot use whenever this negative cycle is there. But when you have some negative weight, you can use what are the methods?
Bellman-Ford.
Bellman and Floyd. But Bellman has a specific in the sense you can find from a fixed source. I mean, you have fixed. So what is the difference between fixed source and all pairs? Just now I told that like fixed source, you have fixed one of the edges and you are trying to find the distance, shortest distance from every other nodes. I mean vertex. Okay. Whereas in Floyd-Warshall algorithm, you can find the distance between any pairs in the graph, and it can have a negative edge weight, but again no negative cycles. Okay, so this is the typical difference between the methods what we use to find the shortest distance in the given graph. It is clear now, no? Like Dijkstra as a Bellman can do in both, like it can have no negative edge and as well as it can have negative edge, but Bellman cannot Bellman and Floyd cannot find whenever there is a negative cycle is there. Okay, so these two methods I'm going to talk about. Where is my thing? Yeah, so this one and this one, Bellman-Ford and Floyd-Warshall. Okay, and any issue, I mean doubt in this, means the difference?
No, sir.
Are you not going to discuss Dijkstra?
So Dijkstra is easy compared to this one, like Bellman and Floyd. Once you understand,
Bellman-Ford is difficult, sir. I think I'm not able to.
Warshall is much difficult.
which one?
Warshall, Floyd-Warshall.
Bellman and Warshall, both are difficult. So that's why I am not discussing this one. And anyway, this will be discussed in the Solve with Instructor session in much more details. So if you spend little bit time by yourself to watch lecture, you can easily understand. That is not too much. That the name is only, if you go and just watch the lecture and try to solve one of the problem, this will be clear. But little bit you need time to understand these two methods. Okay. So I'm just discussing these two methods first.
Yes, sir. No problem.
Actually, Dijkstra also a simple algorithm. If you discuss, it's easy to remember.
If I
Method.
okay, so Bellman, I will talk then that one. This time you see this time you need no negative edge. Can you see the difference? It's
Only
negative,
the negative edge.
but
Yeah.
it can have negative. That is the difference only. So
Yeah.
if
Okay,
I'm
fine.
discussing Bellman-Ford, automatically digesta is discussed. Only you should have no negative edges. That is the difference in the graph you are taking.
Okay, okay, fine, fine.
So why I'm not talking about digesta, because it is just a part of Bellman. If Bellman is negative, edge is not just a case of digesta.
Okay.
Okay, na?
Okay, sir.
Chalo.
Okay.
So before going to that Bellman-Ford model, just I want to like you became that warm up of this. Some warm up questions are there. I mean, I want to find the shortest path this between edge A and D. Sorry, the vertex A and D. Okay, so can you work out on these two? Okay, so I am giving you 2 minutes time.
A, F, C, D.
AFED.
Yes, sir. AFED.
No,
Both are three.
I can see so many.
Yes, AFED, right? AFED.
I can
AFED, sir.
Right, ED.
ABED.
how many paths are you able to get?
ABCD also, sir.
Yeah, so just write for all and try to find the shortest distance among that A to D, means which are the
ABED.
ABED.
What is the meaning of that?
AFED is the shortest, sir.
ABED.
Sir, ABED
AFED
is not
is
the
the
shortest
shortest
path.
one.
Sir, ABED.
Sir,
Yeah,
I can see.
also same.
ABED, sir.
Sir, there's a shorter one. AFCG.
ABED is 10. AFED is 8.
Yeah, AFED. Yeah, also.
That is the
Shortest.
It's
Because
only
8 is.
So which is the shortest one? I mean shortest.
AFED.
AFED.
What is the value?
8.
8 is the value.
E is not possible, right?
Second one, sir, AFBED. And the value is 3.
I think some problem.
Yeah, so, sorry, I was in call, so some emergency call. Okay, so
Sir, second one, AFBED.
yeah, the shortest one is the just me. I'm writing here. So A, F, E,
D.
and D. And what is the value you have?
8.
8. There are other paths also. If you can see here, this is the shortest. Yeah, there are other paths, like from this one you can also reach. No, you can reach. You can reach like
ABED also.
like this also. No, there are so many paths possible, but among that, the shortest one is the AFED. Got it? No.
Yes, sir.
What about in 2?
AFBED. And value is 3.
What is the value?
3. AFBED.
AFBED, sir.
ED. The same value. What is the value now? Minus?
This is also AFED only, minus 6.
AF
minus 6.
Minus
This-
6. This is the
So we can
shortest.
take minus also.
Sorry?
Minus.
Yeah. So that's the value. We can also take the edges can also take negative value.
That is, yes.
That the graph can have. What about here in third?
But
third one.
AFBED.
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 B,
D, sir.
E, D.
A, F, B.
E, D.
What is the value?
-9.
7, -9.
-9.
-9, sir.
-9.
Okay, yeah. Okay, so now my question is that among all these three graphs, in which are the algorithms we can use? In the first, can you see?
First, sir, Dijkstra.
D.
There is no
Dijkstra.
negative.
First
Dijkstra.
one, all three
First
we
one.
can use.
Dijkstra,
All three.
Bellman, and
All three.
Yeah, everything.
Also, we
Every
can use that.
Yeah.
all three.
Second,
Second
Except
one,
Dijkstra.
X. Yeah.
Yes, sir. And third also.
okay, yeah. Okay, now so now you understood know what which are the methods we can use with this example. Okay. Chalo then. Yeah. Okay, so now the Bellman-Ford algorithms. So generally, what we do, so I just explain the method how we use. So there are two things: initialization and update. How we do initialization? So and also the Bellman-Ford model is for only for the single source vertex to every other vertex. I mean, you have to fix the vertex. So wherever you see any question, it will say that first you have to fix the, it will be already mentioned in the question that there will be a vertex which is fixed. From that, you are supposed to find the shortest distance between all possible. Like I'm saying here from B, so B is fixed. So you are supposed to find from B to B, B to D, A, is all, no, up to G. Understand?
Yes.
There can be, it can go through any path, but I am worried. I am only focusing on to find the shortest distance between these. Okay, now in this, I don't mean something. It can happen. Means any edges, any vertex can come, but I am supposed to find here shortest distance. Okay. So in that, what we do, so we define a value dv, which tells that dv is the minimum distance to the vertex v from the source vertex. So dv is like we define a parameter, you can say, where it just tells that minimum distance from vertex v to the source. And why we are I can see the background noise, I think. If someone has I mean, can you please mute, Sandhya and Sridhar Kumar, please mute, no? Yeah. Chalo. Yeah. So if you have doubt, you just stop me and just I will try to clear it out. Okay. Chalo. So what we do in initialization, so dv, so wherever that dv be 0, for which one? If the vertex is b, meaning the source one. This is actually what? Source vertex, no? So from the source vertex, what will be the different distance? We have to initialize as a 0, and every other vertex infinity. So this is the initialization we do when we use method Bellman-Ford algorithms. That is clear, no? I will once I create this one, then you will understand little more. And updation, how we do for every vertex, every edge v to e, which is a member of e. So dk, how we take, so k is a vertex which takes the minimum distance among these two values, d of k or d and dv plus weight or the value from vertex v to k. Okay. This will, you will understand in little more details once I start creating that table. So what we have done, so this was we had the problem. This graph we have given. So here it is actually -4 actually. Okay. Chalo. Okay, so we have created, so these are the V means vertex. So these are the vertexes and vertices, and what these are A, B, C, D we have written, and DV is saying the distance, minimum distance. So initialization in this column, we just fill the initial values, means whatever the initialization we have done. This initialization we have done, we have to just fill here in this one, first one. So only which against which value, I mean which vertex we have to enter 0, which is the source vertex, and what in the question it is given B. So B will be 0. What about others? Infinity.
Infinity.
Agree, everyone?
Yes, sir.
Chalo. Now what we do now, the updation. So also there is a meaning of these tables 1, 2, 3, 4, 5, 6. So iteration or the updation will be happen for 6. Why 6? So how many number of vertices we have? Vertices
7.
7.
7.
7. So number of updation will be
N minus 1.
1. So 7 minus 1 is 6.
Yes, sir.
So if you do these many times, may or may not, means it also not requires distance. It can be you will get the minimum distance for the all vertex from the source vertex shortest distance. But maximum, if you go up to 6, will get the shortest distance from the source vertex. Did you understand what I'm saying? I'm saying that there are 7 vertices. If you update, means if you use this one, you are supposed to, means how many you have to do. So that is the number it is giving maximum. It can have minimum less than that, but maximum if you do 6 times, you will get the shortest distance from the source to every other vertices. Understood?
Yes, sir.
So what we do next, if we see B, what are the vertices are connected? D, C, and E. Can you see this?
Yes, sir.
And they are out degree, means the edges are coming out from the B. So now we have to go and check D. So you can check any one first, it doesn't matter, but just let us check D. So so for that we have to use this formula, no? This formula. And how we are using, just see. So we are supposed to find with D, no? So from vertex B to D. So what we do, minimum, so D of K is what here? D. Just so this D is distance and this is the D is the vertex. D of K is D, comma, D of V. So V is what? Your previous vertex, this vertex, plus W, V of K. So V is what? You have D, sorry, B to D.
And D.
What? Okay, let me. It's actually B.
Sir, can you please begin this line again, because it is not clear. Like
Yeah,
D
yeah.
of D. How...
Yeah, understand. Okay, what I do, I just go for C then, for not having confusion, because these like interface, you're not able to distinguish. So what I'm trying to find distance, means the distance, shortest distance between B and C. So I have to use this formula. Anyway, it is only one direct edge is there. You can simply say here this one, but I want to show that formula how it is used. So D of C, K is here C, no? Minimum D of K. K is what? C. D of C plus W,
B, comma C.
E, comma, C. It is clear? My writing.
Yes.
It is,
So actually, in the beginning, you initialize B is equal to 0, and next, why did you take C and D?
so C, actually, I want to find the distance with B from B to C. So that is a formula we have to use. Among that two, Miss E, Miss, from this one, K is becoming here C, because I want to find the distance from B to C. Okay. And
Sir, W is weight.
yeah, W is the weight, means from edge B to C. This is weight.
So, sir, every time we find on alphabetical order.
No. You can find anyone. I wrote first D, but it was interfering between D and D, so that's why I now use C. That is the only thing. Okay. So I will write this value. We will understand. So minimum D of C is what? Initially,
Sir, degree.
infinity.
Yes, sir.
And D of B was what? 0. Plus weight from
1.
C.
One. Weight is 1.
So minimum. So now infinity and 1. What is the minimum?
1.
1.
So what we have to write?
1.
Source B to, actually what we are writing from source B to C, the value is
1.
1.
Everyone agree on this?
Yes, sir.
Okay. Now what? Same thing. Now we have to follow for now D. So obviously there is direct one here. You can simply put C is here in place of K, C. Sorry, D. Then again this will be infinity, and this will be 0 plus 3. So again for this one, what is the minimum will come? Okay.
3.
3.
This one minimum will be what?
3.
Infinity to 3, no?
Infinity to 3.
Guys, are you able to understand what I'm writing here?
Yes, sir.
Yes, sir.
Yes, sir.
So D, so I can write here 3.
Yes.
What about E also? Why I'm going only this E, C, and D? Because from E, so like sir has given one example of fire analogy. So there, what we have to just, you have burned here from here, this oil depot. It will reach to these no direct resistance. So that's why it is directly connected here. So E, C, and D we are checking. So now E is also there, no? So the same thing for this one. What will be? Minus infinity and minus 4, no?
Yes.
So E will be what?
Minus 4.
Minus 4.
Okay, so one operation is over, and others are, I don't know. So the it will be same copied like this one. Okay. So where we have is E, C, D, no?
Yes.
Yes, sir.
Agree or not? So now we have to check for next. So now, okay. So I'm going to rub this one. It's fine, no?
Sir, computer also do it in n-1 updation.
Yeah, means and maximum. I told you, na, it will go maximum. Means it should come. If you do n-1, it should come. But there is a chance that if there is not 6 edges, means why 6 is there? Means what is the physical meaning here? Means if you want to reach from B to G, if you want to reach a vertex which cover
I know that. I know that.
So that's why I'm telling. Okay, a computer doesn't do, means if it is coming before that is fine, no? And depends on the code actually. I mean, if you write the code in such a way that means how many iterations. Generally, I think if you give generally see what people do, they just write for if there are n number of edges, they do for the n-1 time for the safe sort. But it obviously it will come if there is not so many edges are there. If there is maximum 6 edges in this case, it will come with, up to 6. But if it is connected, like if you see G, how many edges we can have? 1, 2, 3, 4. So I think this will be completed by 4 updation itself. You will get the shortest distance in 4 updation itself. That is there.
Yes, sir.
So now we have reached here E, C, and D. No.
Yes.
Now we have to go for, let us say, D to G. We have to find.
Sir, here one question. Like if I see the graph directly, and from B to C and D and E, all the values I can put directly, no? And if I'm using this formula, how does it help? Like, because if I see the graph directly and I could put the values, what you said, 0, 1, 3, 4, right? -4.
So this will come when you have like, if you do not see the direct cycle, there is a chance that someone like it will come like this. So say if you want to, I will talk these things in once I go for our other 2 vertex where you have some cycle. Means if you want to reach like G, so you can directly from 1 to 5. So 6 is there. But if you reach from like this, what is the value you can see? 1, -4, minus 2, and 5, 0. So you can reach B to G with 0 value. But if you following this one, it will give 6 value. No. So once you do in a systematic way, you will there is a chances is the error in that sense. I'm telling you. Okay.
Okay, sir.
Okay. So this was the first updation you had. Now I'm coming to the next one. So now D to G is there. So again we have to go same thing. So D to G. So minimum. Here we have G. We want to go to reach at G. So D to G. Now here it will become now this one. Plus vertex. Sorry, from V to K. So weight from D to G. And this will be what was the value here? We had infinity. And D to D, what we had? 3, no?
Yes.
From here, first updation. And from D to D, what was the value we have? What is the value?
-1.
This is -1. So this will be, what will be the value? 2, no?
Yes, sir.
So G is now 2. No?
Yes.
Agree?
Yes, sir.
Now, so from D,
Sir, can you please repeat once more this term?
Okay. Is it whatever I wrote is clear first of all? Because I don't know, miss. Is it clear what I'm writing here? No.
Yes.
No?
Yes.
Okay. So we have to go and say we have reached here, no? So E, C, and D. I just chose this one. So D to G I have to, because you can see there's a off degree. Means from here it is emerging and it is ending at the G. So we can go through this way, no?
Okay.
Because this is odd degree. So I have to go to G. So what we have done, just K we have replaced with G. So minimum of E of G, D of D. So now this is becoming here, no? Because this is the connecting directly is from here to here. Because from here to here, you know the minimum distance. I think sir also talked about that. If you are going, if you are reached to some updation, means before that whatever you have done, that is the minimum shortest distance you have found. That is there. Okay. So here, so you have D to D plus weight from D to G, means from the vertex D to G. I have just used the formula only. And how it is working? So D of D, I just take from here. 3, this one.
So, sir, when we do second updation, so we choose the weighted least weightage. The D to Z is -1. So it is.
Yeah, D to G is -1. So that I'm writing the value actually. So infinity, comma 3 plus -1. So it is becoming minimum of these two is 2, no?
Yes, sir.
So that I wrote here just.
Sir, why we didn't take C to G or E to
I will
G?
go to that. But I will go to that. Just I told, no, I just took this one first. Then I will go this one. Don't worry about it. I will go to this part also.
Okay, okay.
Okay, no?
Okay.
So this part is clear, no? Who had
Yes,
done?
Yes, yes, sir, yes, sir.
Chalo then. So now we have to go now. So I see there are only one odd degree from D. So this is over now, no? Because only one we can from D to G, we can only go from D to G, no? Only one odd degree is there. Okay. Now we can have we also reached at C, no? In last updation. So now we just check. I'm just deleting this part. Think about the what will be the value. Just hello. So now C. Now we had C. So from C, from where we can go? How many odd degree are there? Can you see that? Odd degree. Do you understand now what I'm talking about? Odd
Yes,
degree,
sir.
in
3.
degree and odd degree. So
3.
yeah. If there is any vertex, so this is in degree and this is out degree.
Out degree.
Okay, na? I think in CT it is pretty much clear for CT. I think all are doing CT, no? I mean, or
Yes, sir.
Yes, sir.
anyway, Madhavan sir is there, so sir uses both term in math as well as in CT. So from C we can go from where? A we can go to E, we can go to G also. Agree?
Yes, sir.
But we
Yes,
cannot
sir.
go to B, no, because this is out degree. I mean in degree. Can you see this? Chalo. So C to let us say I'm going. I will go this one again, but just wait for a second. So C to A I want to go. Okay. Same thing I will do. Minimum. Where I am going? A. From C to A. So minimum E of C I wrote, no? And D of
Sir, A.
E of A, sir.
Sorry.
A.
Yeah. So D of this is C. Yeah. Just wherever I'm doing mistake, just let me know. I can do this. So V vertex. This is C to A. Correct, no?
Yes, sir.
Yes.
Now you tell me. Now D of A.
Infinity.
Infinity.
D of C.
1.
Yeah, now you just look at here. 1 plus
1
E to A.
plus
E to A.
minus 5.
Minus 5.
Minus
Yes,
5.
What will be the value here?
Minus 4.
Minus 4.
It will be. Agree, everyone?
Yes.
Yes, sir.
Yes, sir.
Now where we from C to E also we can go, no? We can go or not?
Yes.
So now some interesting thing will come here because we have already updated, no? C to E we have already updated with the direct one. Okay, na? Now
Yes.
now we want to where we want to go.
Sir, sir, in the previous slide, example, when you are telling, you told that from the incoming age only we can go, but from E to C there is no incoming, that is outcoming, right? Like
this is
it is the reverse order, no? Like C to E is there, that is coming, but from E to C and then from C to A is there. That's correct, but E to C is not there. That is opposite direction, right? But still we can go.
Yeah, no, C to E is there. No, this is C to E. I told C to E. I want to go.
E to C you told, right?
C to E.
C to E.
Yeah.
Yes.
Did I told like that?
No, sir. I heard that E to C you're telling, so I got confused how it is. So that's why I just wanted to
Go at E through C, because now this one is there. D of E, D of
C.
plus weight function from
C
to
A to
E.
B.
Okay.
Everyone agree this one?
Yes, sir.
Yes, sir.
Yes, sir.
E to E, D to E. What is the value? D to
Minus
E.
4
-4.
How are you saying? From?
from the updated list.
Yeah. Everybody is following this one, no?
Yes, sir.
So D of C, what is the value? This one.
D of C.
1 plus 6.
And W, C to E.
6.
6.
What is the value now? Tell me.
7 minus 4.
Minus 4 comma 7.
7.
What will be the value?
Minus 4.
-4.
Will we update?
No.
No, no.
No.
Yes.
Will we update? No. So this already -4. No, I think B2F already minus. B2E is already -4. No, so we'll not update. No, because
Yes,
this was higher than this value.
sir.
So this will be same -4. We are not going to update. And let me so updating we'll do at last. Means we are not updating value. We will copy at last. Okay. Now
Yes.
again C to G we can also go.
Yes, sir.
Now tell me what will be the value? Anyone?
From where, sir?
To G.
Now
C
from
to G.
what are the left? I mean from
C to G. C to G.
Yes, C we want to go. Yeah, tell me.
It will remain 2. Sir, it's 2.
Yeah, it will remain 2, sir.
It will remain same.
So we have So C to G
G.
we want to go. Now
It will give 2 comma 6.
same thing, no? So what will
Yes,
be the
sir.
value? Tell me minimum. We want to go where? G, no? So what will be the value here?
D
2
to
comma
G.
6.
G already. What is the value we have? 2, no?
Yes.
What is the value here? C
1 plus 5.
1 plus 5.
5. Everybody is following what I'm writing here.
Yes, sir. Yes.
All those who have attending this session.
Yes, sir.
So,
Yes, sir.
to replace the value. Still do 2, no? From this B, D, G. We will not consider from B, C to G. Means we'll have shortest path from D, not from C.
Yes, sir.
Agree?
Yeah.
So we have explored all the things from like D to G. We have explored from C to G, E, A. We have explored, no?
E
Now
still have
what about
E.
E to G? Now we so can you see that from E what is the odd degree with whom it is connected with the odd degree? This one, no? G only. This is odd degree, no? With respect
Yes,
to
sir. Yes, sir.
vertex E. Guys,
Yes, sir.
chalo. So this is minus. Okay,
2
so
comma minus 7.
yeah, I need to delete. Yeah. Are we going to update? Anybody wanted to help?
Yes,
me?
sir. 2 comma minus 7.
Again, we are writing with respect to E. So mean. What is the value of
2.
2.
2? E of
minus 4 plus minus 3
we will write, no? So meaning D of E -4
plus minus 3.
then
-3.
Plus minus 3.
weight value or weight value from vertex E to G.
-3.
It is -3, no?
Yes.
Yes, sir.
Plus, but this is minus in bracket. Yeah, na?
Yes,
So
sir.
what will be the value here? Minimum
2
minus 7.
2
2
comma minus 7.
minus.
2 comma minus 7.
Are we going to update?
Yes, sir.
Yes, sir.
This
Yes,
will be
sir.
here 7. No? So just okay. So minus 7. So everything we have explored from C, we have explored from D to G, which were further updated with some other vertex. C to we have explored A, E, and G. From E we have explored G also. So we have done all the things. Now what we have to do? We have to
A.
copy the previous values also. 1, 3, minus 4, infinity. Agree, no?
Yes,
Yes,
sir.
sir.
Chalo. Now we have, so from here we have reached to, so now let us say from here G. So can you see any odd degree from G?
No, sir.
No, sir.
Will not go further. Now we have to check another one, E. So no, sorry, G. Also G only, na?
A to
I'm
F.
doing a step by step. Okay, I will go there. So from here to here, all again we reach to G, but we cannot go further because it has all in degree. There is no any odd degree. Okay. From E to also it is coming, but E to A we just reached A in previous one, and A to F we can go because this has one odd degree with Anna.
Yes.
So A to F now we can go. So now tell me what is the value here?
Minus 7.
Minus 5.
Minus 5.
Just writing the formula. What I should write here? Yeah, where
Infinite
we
comma.
are going to F, no?
Sir, A to F.
Yeah, A to F we are going. So D to EF.
Infinity.
A.
EA plus weight of
From
Of A to
F.
F.
Guys, any doubt in this? Tell me.
No, sir.
I will give one problem after that. So be careful.
Yeah.
Chalo. So tell me the value now.
Minus 5.
Infinite comma minus 1.
F.
DF. Infinity.
This is what?
Infinite.
And this will be D of A from previous one. Is that minus 4?
Minus 4 plus minus 1.
Plus minus 1.
Value between
Minus
from A to F, I mean the vertex A to F. What is the value? Minus 1.
Minus 1. Infinity.
This will be
Minus 5.
Infinity to minus 5.
Yeah, right.
We burn the vertex to reset the burning time to be the minimum of what we already had, plus the new burning time we discovered through the recently discovered vertex. So if we can guarantee that after we have done this n times.
okay. Parallelly, you are watching this one. Who is this guy? Hello.
Yes, sir.
Why? So, among this, what is the minimum? Minus 5?
Yes, sir.
What will the value here? F?
Minus 5.
Okay. So, we have reached here, no? Can we go further? No, in this one. So, it will just copy this one. Okay? No, miss. From here we reach to G, but G is the like all the in degrees there. There is no odd degree, so this is the stop here. We reached from C to A in previous one, so A to F we have came in this updation. So other things are not possible. From A there is only one odd degree, so we have stopped in this one. So we have to update, copy all the previous values here. Agree, no, everyone? What am I writing?
Yes, sir.
Yes, sir.
So then F2G we will not consider. After that we will consider.
No, now we will come. So in previous updation, means A to F one by one. Now we have to go one by one. So that is the updation. It is coming now. Means age to age we have to go. We are not going from A to G directly from like this. Means we are going in the one age we are considering at a time. Agree?
Okay.
Yes.
Sir.
Chalo then. Now
Next line.
Sorry.
No, sir. No.
Now we have F to G. We have to go. Why? We now in previous one we reached to F. No. So now F to G we have to go. So where is my this one? Think about what will be the value? Tell me.
Sir, mean
0 minus 7 comma 0.
See how it will happen now. See. So where we are going? Tell me. We are going to G.
F to G.
Minimum. E of G. No.
Yes, sir.
E of F
F.
plus weight function from where to where?
0.
F to G.
F.
Now tell me the value.
Minus
Minus 7 comma
Minus 7.
7.
Value?
Minus
comma
7.
0
Minus 7.
comma 0.
Minus 1.
Minus 1
5.
plus 5.
Plus 5.
Minus 5.
Minus 5 plus 5.
Minus 5, sir.
Minus 5 plus
0
5.
sir.
Minus 5
Plus
plus
5.
5.
Minus
Yes, sir.
7 comma 0.
Minus 5 plus 5, 0. Is equal to minus 7.
7 will be the value.
Minus 7 comma 0.
Minus 7. This will be 0.
Comma 0.
What is the minimum
But
amount here?
0. Minus 7. Minus 7.
0 or minus 7?
Sorry.
ठीक है ना?
Yes.
This will be 7 minus 7 only, no?
Yeah.
Yes, sir.
From this way, so from this way we are going, it is becoming 0, no? But other way, what was the other way? From B to E and G, it is coming minus 7, no? So that was remained. I mean, we haven't. In that sense, we haven't updated in this updation. Means we have compared. But we retained the previous updation value. No, this will the 0.
We can start only from B updation sir.
Yeah. Sorry. Can you come again? What did you say?
Can we update from A?
A
Start
to?
the updation from A. No.
Miss source you are saying. I mean, miss, I didn't get what you're saying. A to where you want to go?
Can we start updation from A? In the starting, from
No.
starting.
So
No.
so we are going a step by step. A to where we want to update means from A to which one you want to update?
As we start from B.
So
Update.
you can do from A also. It's fine. So what you have to do? You have to make it initially this one 0 and everyone
Infinite.
So this is the like in this we have explored all the things, no? G, all the. So this is actually the minimum value you have got, the shortest distance among. You can also cross check, meaning if I say that from B to F, what is the minimum? You can see the graph actually. How to reach B to F? First of all, tell me. You can have only how many options? I think only one option, no? B, C, A, F. That is the only option, no?
Yes, sir.
And can you tell me what is the value here? Minus 5. I can see
Yes,
the
sir.
minus 5 value is there, no?
Yes, sir.
Let me do it. Yeah. This one, no? This is better. Yeah. You can check anywhere like G. G had many paths. G had many paths. You can come through B, D, G. You can come through B, C, E, G. You can come through B, C, A, F, G. But among that, what is the minimum? 7. Which one? From this one, B, E, and G. No. So this is the final one. So we haven't gone to the all the n-1 values, means 6 updation. We got it. We ended up here only, means after 4 updations. So this is the initialization value, and these are 2 the.
No, I meant to say that just as we go for topological sequence with in degree 0.
No, I didn't go for topological. No, I mean.
But B has here in degree 0. I thought that we start from that node which has in degree 0.
Yeah, so this one has in degree odd, see, this has odd degree 3, in degree 0, correct? Yeah. We can choose any source vertex, I think. We can choose C, we can choose E also.
Can you please summarize it once, all at once?
Yeah. So what we have done, so if a problem, see, if you see the problem, this problem was given, and you are supposed to find the shortest distance from the single source. I mean, this is the problem of single source vertex, and I'm using the method. What is that? Bellman-Ford algorithm. So Bellman-Ford algorithm, what it does, it has two steps. First one is the initialization, and next one is the updation. In initialization, what we do, we fix. I mean, if we we are given one value vertex which is called source vertex B, and the value against means the mean. So we have defined a parameter, you can say dv, which tells about the minimum distance from vertex V, sorry, from the source vertex to the vertex V. Okay, so if so this is the initial values, means you have to initialize with the some value. And how we initialize? So the value against source vertex, you have to enter 0, and for all other vertices you have to enter infinity value. That is what I have done. Means since we have told that in the question that B is a source one, so we have initialized with a 0, and rest of the vertices so dv is actually what it is, the minimum distance. So initially we don't know, so we are just defined with the infinity, and we just put the infinity. So infinity, infinity, infinity. Can you tell me like if okay, first I just complete this one, then I will tell. Update, now dv is there. So for once you initialize, then there is a comes updation. Updation comes to find the shortest distance as we move forward to the next vertices. So for that you have formula. You just compare the two values. What is that value? So if we want to find the shortest distance from source to vertex K, I have to compare the value d of K, and dv means the source vertex plus weight function or weight value from vertex V and K. Means between V and K, you have to enter you have to just add the weight value, and then you have to compare, means among the two values, whichever the minimum, you have to enter in the that particular updation that is there. So I want to just ask you one thing, like if after that let us say it is here we have ended with the in 4 updation itself. If we go for 6 also, if some of the vertex like let us say imaginary one, something x1, and it come infinite, what do you mean by that? Understand what I'm trying to ask here? Miss,
It is disconnected.
Sorry?
Disconnected, disjoint from the graph.
Disconnected. So disconnected, you cannot say if it is given here, so you are entering actually the value, no? So this is not disconnected. Something is there.
We cannot reach from the source vertex.
Source, yeah.
In degree,
Yeah.
sir, in degree should be 0 for the source vertex.
Sorry?
In degree should be 0.
No. So in degree with respect to, say there can be in degree will be 0. Let us say B has in degree 0. So that time it is value 0. I'm asking for the negative. We never updated this one. Means we didn't get to reach the
Sir,
X.
you are asking about the source vertex.
Sorry?
Are you asking about the source vertex?
Yeah, with from the source vertex.
Yes, sir.
After updating, means after updation 6.1 iteration, means 6 updation, some vertex still the dv is the minimum distance is infinity. So just wanted to tell what it just represent.
That vertex is unreachable from source vertex.
Yes, from this source vertex we cannot reach to the X. That's why we say generally, like we cannot reach to the very like galaxy. Now it means other stars. So we say the infinite. Now it is very much measurable. But we generally say what is the distance between from here to another galaxy? We say infinite, but way too high, no? Like
Yes,
that.
sir.
Chalo. So can I give one question or no? What do you
Can you please brief
so what do you do?
traversal path, how we traveled from B, please?
Sorry.
While preparing this algorithm, how we traveled from B transversal path, can you please explain once?
Traversal, see.
We started with B and how the updation.
Yeah. So see what we have done. So let us say you have just put fire here. This is the oil depot. The same example what sir has given.
Yes.
So I just put a fire here. Which are the vertices it will reach? I'm not talking about the time actually. Since, obviously, whichever the less time it will reach. Just I want to know which are the vertex it will directly reach from B to other vertex.
Yes, DCE.
ECE. Okay. Now your fire has reached here. Let us say D. No.
Yes.
We'll go one by one. So in this case, just I'm taking D. So from D, where we can go?
G.
It will go to C. Now it will not go to C. No, because
no. Only G.
Only G. Then we have explored. Means we have updated this one. Now we came here this value C, because in the same previous one it has reached here. So we have to also explore this one. So from C, where we can go. Wherever the odd degree is there from C. So from C we can go to A, E, and G.
Here I have one doubt.
Tell me.
While choosing from C, D, E, among those, do we need to choose the lowest weight one or any one we can choose? Because C will burn quickly, right? It's only one weight having B to C.
Yeah, so you don't know what it is actually. This is I'm just saying that it will burn in that step. I'm not talking about in terms of time. Yes, if you talk about in terms of time, which will burn first? Obviously, C will burn.
So if no condition, then we can choose anything, any vertex.
But see, this for this particular graph, that is not applicable because we have given minus value and time doesn't have any negative. So just understand that means I'm saying that once you put here fire or something, it will come here. Which are the vertex which will directly come. So we deal in updation only one edge one time. That is the thing I'm telling. No.
Because why I'm asking this doubt in Dextra, we will move with lower weight ones, right?
So that is updating there, So that method is followed.
Okay.
And also we are also doing the same thing. No, last time somewhere in I think from -7 it came and so this one actually among whichever is the among this 7 and 0 previous. So obviously this was from different path and this is from the different path. So among that we have compared and we just compared that and we found that -7 is minimum. So we chose that one. So minimum weight actually you can say.
Okay, after DCE, where we traveled, I'm not getting this one.
Yeah.
DE.
Yeah, so then after just a minute. Just this part and okay, this is so what so B is sorry. Yeah.
B, okay.
B is the source. This is the source actually. Source vertex. Okay. From here we have this one, this one, this one. Agree?
Yes. Yes.
Now we are supposed to choose anyone first. I don't care about the sequence, means alphabetical order and anything. And it is just tell me which should I take now.
C.
C. Chalo. So C I'm taking from C. Where are the which vertex we can reach? Which are the vertices we can reach from C? We have to check the
G.
Yeah. We can reach A, E, and G. Okay, na? So from here we can come here. We can come here. We can come here. No.
Yes.
After that, what should I do next? E or D? Tell me which one. Anyone we can do from D. Sorry, E. So see from E, what is the odd degree here? Only this one, we can from E to G, we can go here only. We cannot go reverse.
Yes.
We cannot go to C. We can only come here. So from E to G, we can come here. Now we left with the D. Okay.
Yes.
Now we have come here. A. Next one. So A, where we have reached A and G, no? A and G.
Yes.
So G, can you see any out degrees there?
No.
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 No out degree. No out degree. Okay.
Yes.
What about A? You can
Yes.
F also, no?
Okay.
From here we can come here. We did updation, and now we have from AF to. So see, we have explored all. We have explored these all the edges, no? We haven't explored in. So we have to explore in next updation from AF to G. We can also reach, no? Because it has one out degree towards G. From here we can come here, but after that there is no out degree here, so we cannot go further. Okay.
Can we compare it with the DFS tree? The exploration, is it similar like DFS?
Yeah, it's actually that
Yeah.
is, yeah. So what I'm telling, can you draw one thing for me? I mean, I will tell the final value for that one. Just
Okay.
instead of here -4 is there, no? Can you do for like let me draw itself. Otherwise,
Sir, if the undirected graph is there, so how to compute them?
undirected. I don't miss. Undirected, what we can do? We can go anywhere, no? Cycles is there. We can go anywhere like that. We can go like this also. My cursor is, you can see, no? So undirected, I haven't seen this. I didn't watch further. Like, what is there? Anybody have watched that one? Sir has explained.
No. These algorithms solve with
Undirected.
undirected. So directed.
I think.
D, yeah,
Directed or cyclic. Yeah.
only for DAG.
Yeah, DAG only. Yeah. Maybe further it can have some with some modifications. It can have. I'm not sure. That's why I'm not commenting. So it is okay. So all things are same. Means all things are same. From B to E is here. B to E is there, na? Here I'm just telling it is 4. From B to E is there, na? It is only for rest of things are same. So can you quickly write this one? It won't take much time. In 5 minutes you can do this one. Just do it fast, no? If you do now itself, your half of the doubt will be clear now itself. If you are getting any doubt, just let me know. So did you understand what I'm trying to say here? All things are same except, what is that? E to E, and the source you just keep same B. Okay? This consider this is source vertex. Okay? Hello. So the values are 3. So this is 3, same value. Only the difference. This is 5. This is 6. This is -3. 5 -1 minus. Okay, so just try to find this and minimum distance from B to every other vertex. Okay?
And it will be F.
E to
F.
What is that? B to C? I have drawn. Oh, sorry, sir. Sorry, sir. This is 1 actually. Okay? Sorry.
Then answer will be B to F.
B to F. No, I'm just, I am trailing you to draw this one for this cycle. I mean, this graph.
Okay.
This,
Matrix, sir.
yeah, this is actually not a matrix. Matrix, it should have
A square.
not a square.
And change.
This will be A, B, C, E, F, and G. How many are there? 1, 2, 3, 4, 5, 6, 7. So it will really, actually, this is for the initialization. So this will be the initialization, and rest of the 6, 1, 2, 3, 1, 2, 3, 4, 5, 6. Yeah. So you are supposed to fill this to get what you will get.
Sir, can you scroll that formula, please?
Scroll up or down?
Up.
Yeah,
That
but
formula.
so only the difference between here it was -4, here is 4 only. Okay, chalo. Okay, so I can see a lot of back. Okay, those who are not talking, just mute yourself. Let others to. Well, I can. Yeah, just I'm giving you 3 minutes. It's fine. I will just give you 3 minutes. Fine. Yeah, I come in 3 minutes.
Yes, sir. I'm done, sir.
Anybody got?
Yes, sir.
Yes, sir.
Still writing.
Yes, sir. Yeah.
Okay, so I'm going to write, and you can cross check. Okay. So first will be I will just change the color then. Everybody tried actually at least. The first entry is
Yes, sir.
easy, no?
Yes, sir.
What about second entry? What should I? Here it will be infinity. Here it should be 0. What about here?
1,
1.
3, 4.
3, 4.
Infinity.
Infinity.
Everybody agree? Everybody has
Yes,
got
sir.
Yes, sir.
Yes, sir.
next 4.
0, 1, 3, 4, infinity 1.
Minus 4 is correct.
Yes, sir.
Yes, sir.
0. Then
0, 1.
1,
1, 3, 4.
3 minus 4.
4.
4,
4.
4.
4, sir. 4.
infinity
But in the third row, it's infinity.
This will be infinity.
1.
Minus 1.
1.
Sir, for the third row, the third column,
Uh-huh.
it's infinity.
A should be infinity.
Yes.
Yes.
How come?
A should be,
From C to C, from C, A we can reach, no?
yes, sir.
So this will be minus 4, no?
Yes,
Yes, sir.
sir.
Minus 4.
Hello? It will be minus 4, no?
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
Minus
sir.
4.
We can reach.
What about here?
1,
G.
1.
1, sir.
1, sir. 1.
It's 1, sir.
How come 1?
E to G.
Cos E to Z, sir. Yeah.
4. Infinite, comma, 4 minus 3.
From
Yes.
here, here
4
we are
plus
checking
minus 3.
here to here. So,
Yeah.
see,
Wow.
actually one path is here. From here to here, it will be 6. But also from here to here, 2. But what about this
But
here?
first it will become 2, then it will go to 1.
Yes, sir.
4 minus 3 is actually,
2.
sorry, 4 minus 3 is actually 1, no?
There are
Yes,
3
sir.
paths, sir.
D
And
to
the
G.
minimum one is this.
There are 3 paths. I
Yes,
tell
sir.
you which are the paths. This guy, okay? This
This
guy,
will give 2.
this guy. So this is what is
Minimum.
the value? 2. This is 6. This is
6.
1.
Or then it will 1.
okay, na? What about here? Tell me.
1, 1.
From where we are going? A, no? Why 1?
Yes.
Shortest. Minimum. Sorry.
Chalo. A, where, from where to where? We have to, now where we have to go?
A
A.
to F.
A to F.
No, I'm telling you the value of here, A. It will be same, no? Minus 4, no?
Yes, sir.
Yes.
Yes, sir. Minus 4.
Yes, sir.
B will be 0. What about here? C?
1.
Will 1?
1.
It will be- Okay, you are talking about the updation in this. I was just copying. Okay. So here it will be F will be how much you are saying?
F.
Everything will
Minus
be copied
5.
only 5. F.
Minus.
Yes,
Minus
sir.
5, correct or wrong?
Yes,
Yes,
sir.
sir.
Yes,
Yes,
sir.
Correct.
sir.
Correct.
Minus 5.
D will be same,
1.
no?
All other.
Same, sir. D will be 3.
They will be copied, sir.
Others will be copied, no?
Yes.
Yes.
Yes,
sir.
Chalo, idhar aao, idhar. Chalo, now here. This will be minus 4. 0.
Yes, sir.
Where will
Sir.
F to G will go now, no?
Yes, sir.
Yes, sir.
The G will be updated and everything will be copied.
What will be the value here?
0.
0.
Okay, na?
Yes,
Others will be same, no?
Yes, sir.
Yes, sir.
How many have got this value?
Yes, sir. I got.
Yes, sir. I got it.
Yes, sir. Me
Yes,
too.
sir.
Now some confidence is there?
What, sir?
Some confidence you got to solve this.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Chalo then. Should I go to next one or fine? This is clear now, no? I mean,
Yes, sir. Yes, sir.
Yes, sir. Clear.
Sir, over here, how do we really identify which is the shortest path? We can do it through the matrix and understand which one is going where.
the shortest path you are saying. I mean,
Yes. How do we identify from each vertex to another?
so if you see the graph simply here, I mean, so from the graph you are trying to say?
We can see, I don't know, from the graph or the adjacency matrix.
Yeah,
The
so
matrix.
if you we are keep updating here, no, this will become the minor. So because see why it is ended with actually 4 actually means 1, 2, 3, and 4 updation only.
Yeah.
The farthest vertex from B is connected by 4 edges only. 1, 2, 3, and 4.
Yeah.
Anyway, we can reach to here also. So we have checked. Can you see this? We have explored all the paths to reach G.
Yes.
These are the path, this path, this one also. And what about this one also? So actually within the operation, we compare this. Where is my, this one? We compare all the values within the actually this path, and final value we write here.
Yes, we wrote the final value, but we didn't keep a record of the sequence
So
and how we reached the zero.
Yeah, so previously in previous iteration with the previous value we check, no? I mean, with the previous operation we compare, no? I mean, this one we compare with the previous, means dv is reached means up to the previous value. We take what value we put here, means the previous operation value, no?
Okay. It will be in our workings.
Sorry.
It will be in our calculations somewhere.
Yeah. This is actually representing, means you have explored this one, means up to this one. These are actually saying the minimum value. Once you go to the next vertex, the edge value will be added to that value, and then it is compared. If it is minimum, that will be updated, otherwise not. That is the summary of this one, this method, no? Bellman-Ford algorithm, no?
No, I understood how to get the value zero. What I was saying is that without really going through the graph, looking at the matrix alone, we can't identify what is the path to G that gives us zero.
Path you cannot tell.
Yeah, that's what I was asking.
Yeah, path you can tell.
Sir, then what will be the significance of this n-1? How do we, represent that value here? Because as we go here, we can get maximum 4 operation or like maximum 5 operation we are able to do here using the graph and this particular method. So the significance of n-1, when do we use that?
So that you can check with what, like from the source vertex and the farthest vertex. The source one, source vertex is B, no? And farthest one, which one is the G1? G, no? So from B to G, we have used only like how many? We can go through this one. From this to this, so 2 edges are there. From here, so 1, 2, 3, and 4. If it is connected by maximum, it can have how many edges? I mean, if there is no any cycle. I mean, if there is a cycle, you can have more than in what is that? What edges? But if there is no cycle involved in this case, to reach the farthest one, it can have maximum n-1 edges. That agree? And do you agree on this?
Yes, sir.
Yes.
That's why we update up to the maximum n-1. Okay. So in this you cannot see there is any what is that cycle? There is no any cycle, no? And that is the formula we have. Negative cycle. Positive cycle, I think we can use that one, but in that case it will be the repetition actually. That will
so
be.
I mean to say, if the positive cycle would exist here, then we would have reached to that n-1.
So also if there is a positive value, it will be keep adding it will be the maximum, it will be becoming higher value. So obviously we have to, in the next this minimum, whenever we will check the minimum, we have to discard that value. Now we have to check the minimum. So as you go one up cycle, you will add something. If you go next cycle, you will add the same value, no? So that will keep increasing. So anyway, that is discarded with this formula, minimum of this one, no? Whereas negative cycle, that's why we have avoided in the, we should not have any no negative cycles. So the formula is this n-1. With respect to that, we should have no any negative cycles, and that is interrelated with each other. So if G is connected farthest maximum is 6 edges, since there are 7 vertices are there, so we had to go for the up to 6 updation to get the minimum or the shortest distance. Okay.
Provided we do not have any negative cycle there, right?
Correct,
Negative
correct.
paths.
Yeah, that is the main thing. Yeah.
Of course. Thank you, sir.
Next we have Floyd-Warshall algorithm. So what is the difference from previous to this one? What we are going to do here? Tell me. There we have fixed one vertex. Here we are not fixing any vertex. If these are the vertices here, so we are supposed to find, let us say if we are finding, this is black and blue, red I want to use. Chalo. So if here what this will do that pair means 1 2 3 4 5 6 7. So there are 7 vertices are there. Okay. How many pairs it can form? N into n minus 1 by 2, meaning 21 pairs. Means A to B, like A to B is there, then A to C will be also there, A to D will be there, so all means up to G. Then B to A we can write or not here?
No, sir.
No,
It
sir.
divided by 2.
Yeah, so since it is pair, it is saying B to A we cannot write here. But B to A we can reach with some other. Here I think it will be like only this one pairs we are checking. We A to B we are reaching from this one. So B to A we can reach from some different edges with the following different, not directly direct.
Closer transitive.
From some another K will be there in between. We can reach also. So here it will be actually 42. ठीक है ना? That many distance you can get with the pair. So here we are not fixing any source vertex. ठीक है? Floyd-Warshall algorithm, what it does, it just find the shortest distance between pair of vertices. चलो. So first I just talk about what it says. So let SP means shortest distance. Okay. I to J be the shortest path from I to J via vertices 0 to K minus 1. So this is the like definition of that Floyd-Warshall algorithm. So if we're writing SP0, the shortest distance, what it is mean, I will tell you. So SP0 with I to J, it's just a initialization, you can say. This is the initialization where you have to enter the weight values between that pairs, means the vertices I to J. So whatever the value, if I and J are vertices, edges are there, then you have to just enter the value corresponding that cell. Means you have to create here a matrix. So it is simply just nothing but SP0 is adjacency matrix, where we have written 0 where there is no connection, where we are writing all the values, no connection with the infinity value. Okay. So that, and SP1, how we will get SP1, the other matrix? So we have to reach from I to J via 0. Wherever this one is there, na, you are supposed to do. Can you see this one SPK 0 1 2 3? Then you can go K minus 1. So here 1 is there. So 1 minus 1 is 0. So you can have, if you want to go from I to J, you can choose 0. So 0 to, so here it will be what? I to 0 and 0 to J.
Sir, one hop.
Sorry?
Sir, one hop like.
Correct. Yeah, CT. One hop. One hop. You can change one train.
Yes, sir.
A train later. Nice. Yeah. So the same thing now if we have SP2. So what will be the so SP2 I and J? So what will be the vertices you will have? 0 and 1. what we can do? So I to j, if you want to go, you can go to like this one. This is also possible. Like is visual, no? Yeah, or I to 1 like that.
Okay, sir.
Chalo. So this, and now it can go for the SP7. So whatever the vertex you have number. So here number of vertices are 7.
7.
Okay, na? And that will
Sir,
yes.
here at SP2, you mean to say that two intermediate like vertices will be
You
there?
can have two possible. Either I to j, if you want to go. It is not clear actually. Let me write somewhere. So I to j, if you want to go in SP2, and this is the via vertex, intermediate one. So you can go I like this one, or you can go like this also. Okay, intermediate.
Okay. Maximum two can go, but minimum also one can have.
Yeah. So the same thing, SP7 now, this is a general, you can understand that 0 to 6. Okay, SP7. Now we have to fill this one. How we will fill? Just put a little bit attention here. Then yeah. So SP0 is just a adjacency matrix, except we are adding here infinity value wherever there is no any edge. Okay. So tell me what should I write here? 0 to 0?
No, sir, infinity.
0 to 1. Infinity, no? So what I do, just I write for the connections actually. So 0 to 5 is connection is there, no? 0 to 5.
Infinity.
This is -1?
Yes,
then
sir.
Yes.
1 to 3 connection is there. Oh, sorry, 1 to 3 connection is there. What is the value?
3.
3,
1 to 2 is also there.
1 to 2, 1.
1 to 2.
1 to 4, 4.
Right, yeah, na?
Yes.
Then
yes, sir.
The rest are infinity.
yeah, rest are I will fill. These are infinity.
Yes.
Then 2 to 6 is there. Connection is there.
Yes, sir.
What is the value?
5.
2 to 4 is 6.
2 to 4 is also 6. Chalo. Then 2 to 0.
2
2 to 6 is 5.
No, 2 to 0 is also there, na?
Yeah,
Yes, sir.
that is
2 to 3
-5.
also -5.
-5.
Yeah. And other things are 0.
Infinity.
0.
Infinity. Sorry. Yeah. Now 3 to what is there? Only 6, no?
3 to 6.
Only
3 to 6 is there, -1.
-1.
ठीक है ना? Then 4 to
4 to 6.
4 to 6 only.
minus
3
-3.
all
Rest
are
are infinity.
Rest infinity.
then 5 to
6.
5 to 6 only 5.
Only rest are infinity.
Rest is infinity.
no, because there is no any
Outgoing edge.
Out.
Is there any shortcut, or do we need to fill all these 7 tables in this algorithms?
there is no any shortcut. Since I think these type of problems comes, no, I think, I don't know, it's math question. I think, but there will be less number of edges, I think, for 3 to 4 edges. It might have asked. Yeah. So now we have
Normally drawing tables, 7 tables, it will consume a lot of time.
yeah. And that is the time taken actually. So maybe they will give you the for smaller number of vertices. Yeah. So now what I was supposed to do, SP1. Okay, na? So SP1, how what are the vertex, means through what vertices we can go? Tell me.
0
One more.
0
to 6.
तो चलो wait करो So 0 is there now. So with 0, which are the vertices we can go from 0?
0 to 6.
This is the one I am talking about. So can we go
2
to 5?
2 to 5. 2 to 5.
0? So we can go here.
Yes. That's it. Only 2 to
Oh,
5.
we can write here now. We can go 2 to 5. 2 to 5 via
0.
Agree, everyone?
Yes.
Yes, sir.
And what will be the value here? 2 to 5.
-6.
Minus 6 it will.
1. Total?
-6.
Minus 6.
So we have to update. So 2 to 5 we are going. And this is the is not clear. Minus, no, sorry.
-6.
Everybody agree this one?
Yes.
Yes.
Can we write for others also? Can we go other edges from with 0? And we can only use 0 only.
No, nothing.
Nothing, no? So rest of the things we have to what?
Infinity.
Infinity only.
Not
The
infinity.
same as the previous.
Earlier.
Yeah,
SP0
earlier
to
table
copy.
whatever.
So we have to
SP0.
just copy.
Yes.
You know how much work? So I'm writing minus
Write
1.
only the values.
Yeah, values I'm writing. See, so let's just know is here it will be 2, say 1, 3, 4. Just watch here. Maybe I can do mistakes.
-5.
4, say
2 to 6.
and this will be 5, no? 2 to 6 we can go.
Yeah, there is 5.
Then we have 3, only -1.
-3, 5 down.
Then 4 may -3 we
-3 and the down 5.
can. Rest of the things are
Rest
infinite.
all infinite.
Guys, you have to fail actually this one. I'm just leaving. It doesn't mean that you should not fail. ठीक है ना?
Yeah, it's okay, sir.
Now we sorry. बोलो.
SP1 जो टेबल है इसमें only we are taking the zero considering zero this via zero only we got this only one, but are we considering other things which has the possibilities of having a only one intermediate
only one we are
let us say 1 to 6. If I plan 1 to 6, I would also have one intermediate, that is 3, no? 1 to 6.
Just a minute.
It should be via source vertex, via 0 only.
Sorry. What did you say? Please, can you repeat it once again?
Sir, is it that only 0 we need to consider, or we also can consider the possibilities?
Only 0. Whenever we are creating SP1, we have to only consider 0. Only consider 0. That is the rule, no? Where is my rule book? This is.
So 0 is the source word.
Not source. We have to pass through that one. Okay. What? I agree. No, I mean this is the rule actually. I mean
yeah, via through.
Now we have to create SP2, and what is the values? I mean you have here. So again, and this will be 0 and
1.
Okay, na? So 0 and 1 is there. Can we go from 1? First of all, check 1. So 1 can be via to any edges. I mean, can we use 1 through can we go from?
No, sir. No in degree.
Okay. We cannot use. Okay, what about 0, 1? We together want to use. So 1, 0. So we have to use 0 and 1 together. Is there anything?
1 to
1 to 0. 1 to 0.
3 to 2. 1 to 2. 2 to 0.
1 to 2, 2 to 0. No. So 1 to 2, 2 to 0. This one you are saying.
SP2 we don't have.
So this
SP2.
You are using this one via 2, but via is
No, sir. That is wrong.
No,
via 0, 1, no. For SP2, no.
We cannot use
Intermediates will be 0 and
none of
1.
that for either for zero. For zero, obviously we have all we have already used here. What about one? One we cannot use. We cannot go now. We all are odd degree. In degree is not there. We cannot use one via. Agree this
Yes,
one?
sir. Yes,
Same.
sir.
0 1 0 1 together. So 0 1 is there. So chalo 1. So 0, but in between something is not coming. Now 3 is there or 4 is there. But what about, can you see this? All are out degree. In degree is not there. Here also, if you want to go 0, no, 2 is coming actually. No, 2 is coming. So you cannot use, sorry. You cannot use 1 0 1 here because 2 is coming in between. So this is not possible. So it will be same as SP1. We are not doing anything. We are not updating anything. But
You mean to say like 2056, that will also not be considered because it is not considering 1?
Same as just SP1. We cannot use 0 1 also because in between 2 is coming now, but 2 is not in this list.
नहीं अगर 2056 हम लेते हैं 2056
2056
but it doesn't consider 1, so we are
5 is coming. So 5 is there in this list. This list is there or not? Not there.
No.
We cannot use. Cannot use, no.
Yes.
Everybody got it. SP1. So SP1 will be same. I mean, we haven't updated anything. So again copy 1. Chalo 2 से start करता हूँ. 5 minus 1 minus 3 5 1 3 4. This is minus 5, no? Minus 5 6 minus 6. This is there. So we haven't updated anything. It will be same as SP1. And why it is so? Because we do not find any pair of vertex which goes through 1 or 0 1. ठीक है ना?
Yes, sir.
Agree everyone? Chalo. Now we have to move to SP3. ठीक है? SP3, what are the values we'll have then? Tell me. 0,
2 1 2
and 2.
Yeah.
So how we can go here now? Tell me. Can we go? So one by one we take. So can we go 1 to 4 via 2?
Yes.
1 to 4 via 2?
Yes.
1 to 6
Yes.
via 2?
Yes, sir.
1 to
0 via 2.
via 2?
Yes, sir.
This was easy. So let us update this one. Okay. We'll come to next also. So 1 to 4 we have via 2. So what is the value? 1 to 4?
7.
7.
1 to 4 via 2. So this is 7. But what we have value, no? What is that? Let me copy this one now. Tell me the values actually. So this is actually 0 ka 5 mein na? This is problem to write all the things. And also, yeah, table 1. So this is 1 3 4. This is 6, minus 6 5 minus 1
minus 3
minus 3 and
5.
This is also
So 2 to 0 minus 5.
2 0 minus 5. Yeah.
I was talking about 1 to 4 via 2 I want to go. So 1 to 4, what is the value? This one 7.
7
7 plus 4 11.
1 to 4 via this is actually already we have 4. We will not update. Shortest we are checking, no? Shortest.
Yes, sir.
So we are we going to update?
No.
No, sir.
no sir
1 to 6 via 2. 1 to 6 via 2. So what is the value?
6.
6.
So 1 to 6. Previously it was infinity, no?
Yes.
This
Yes.
was blank. So this,
Yes.
Yeah.
this was
Now
infinity. Whatever the blank is, what do you mean by that? These are all are
Infinite.
infinity, sir.
and infinity with respect to what is the value we got? 1 to
6.
6.
Six.
No? So we are 1 to
Yeah, 1 to 6 via 2, 6.
agree, no?
Yes, sir.
Yes.
1
Yes,
to 0 via 2. 1 to 0 via 2. What will be the value? -4.
Minus.
-4.
I am going like this.
Yes, sir.
Yes, sir. -4.
Okay. So -4 it will be 1 to 0. 1 to 0. This will be
Minus.
-4, no?
Yes, sir.
Yes, sir.
I should use the green one, no? This was last time, no? 1 to 6. 1 to 6. Chalo. Next one, what I 1 to 0. So this will be -4, no?
Yes, sir.
Okay. Now, tell me, can we use something also different? Can we go 1 to 5? 1 to 5. I'm just listen. 1 to 5.
Yes,
Yes, sir. SP3, no.
Yeah. 2 0.
Yes, we can go 1 2 0 5.
-5.
1 to 5 we want to
-5.
go. 1 to 5 we want to go via 2 0. Is it possible?
Yes,
Yes,
sir.
1 2
Yes, sir.
0 5.
1 2 0 5.
Yes, sir.
What is the value?
Possible.
-5.
-5.
-5.
1 to 5 is minus.
-5.
-5.
Take other possibility. Anything other is with this combination. It is coming here. See, 0 1 is not 0 1. We have already checked. So 0 1 2 3 0 1 2 is together. We can do so 0. So 1 to 2 2 to 0. From let's so this is a 3 to 5. We cannot go because this is
Sir, this. What is this, sir?
sorry. So we cannot go, no? Sir, hello.
Yes.
Yes.
Yeah. So other possibility, any other possibility is there? Just think.
No, sir.
No, because of this, we want to use like all 1, 0, 1, and 2. So one thing we can see that 0, 2, and 1 is there, but this one has odd degree. This one has odd degree with respect to 1. So we cannot go here. Okay, na? So we cannot go that possibility. So this SP3 is updated now. Now we have to update SP4. What are the values we have here?
0 1 2 3.
0 1 2 3.
Where is my green one? Red, sorry. 0 1
1
2
2 3.
Now tell me what can we do here? So
1 to 6. 1 to 6 by
1 to 6 we can go.
Yes.
by 3.
1 3 6.
How we are going? So we are going like this. Just let me delete this part. We are going 1 to 6. How?
1 3 6.
1 3
by 3.
Where? I just lost.
1 2 0 5 6.
1 3 6.
1 3 6 the shortest.
Let's decide how we are going. 1 to 6 we want to go. How we are going?
1 2 0 5
3 6.
We'll go 1 3 6 first.
1 3 6 first. What again? 1 to 6 we want to go. How we are going? Tell me.
Via 3.
Why 3?
Via
No?
3. 1 3 6. Yes.
That's simple. You are telling it to do. So we cannot go now because 5 we haven't in this list, no?
Yes, sir.
And also 4 is also not in this list. So we cannot go like this now in SP4.
Why?
Why?
In this list,
Ages are only 0
We
1
have
2
to.
3.
We can go now. Via 3 I am traveling.
yeah.
Via 3.
1 to 6. This is okay, but I was talking about this one. This one is not okay because 4 is not in this
Yes,
list.
sir.
Yes, yes. We are not talking about that.
But we cannot use 5 with the.
ठीक है ना?
Yes.
So tell me the value.
2.
2.
1 to 6, 2.
1 to 6 to 2.
Yes. 2.
Anything you tell me, any possibility we can do. So chalo.
1 2 0 5 6. Anti-clock.
1 2
5 is
1
not
2
there.
0 5 6.
5
I
is,
can't go through 5.
we cannot use.
Okay, 5 we cannot do.
Okay, where are you going? Tell me. From which vertex to which vertex? Tell me. While using only this set of vertices.
There is no possibility, sir.
Not
Only
possible.
one.
Let's do something.
Copy
0 to 6.
copy.
Yeah, let us say 2 and 3, but 2 3 is not connected. 1 2 we have used in previous.
1 2 0
Copy the
5
rest.
we can go now. 1 2 0 5.
1 2
2
0
0
5.
5.
So 1
We
to
have
5
done.
we have already done in previous one. 0 2.
Yes.
Yeah.
Yeah, we are not going to update. Okay.
Copy the rest, sir.
We have
Yes,
already
that's
done, na? This one. Then why we want to do?
Yes, we did it right.
So,
So
only
nothing
one
else.
thing, only one updation is there.
Yes.
Anybody can think other updation. 1 3 chalo. But this 1 3 is connected chalo. With respect to their odd degrees, in degrees not there with respect to 1. We cannot go. But also this side, if we want to check if from this side, but also again with 3 there is no any in degree with respect other than that, because we are using 1 and 3 together. This possibility 1 and 3 we are using. So 1 3. So if you want to use it, should either it should come like this or something like this. No, but this is not possible because this is restricting for this one, and for this is restrict. This one is for this one is this is restricting because this is odd degree. No, so 1 3 combination is not possible. Guys, are you with me?
Yes. Can you
Yes, sir.
repeat?
Chalo then.
Copy the rest, sir.
Sorry. Copy the rest. Nice. Where I 1 to 6 earlier it was 6, no?
Yes, sir.
We didn't compare. See, so we have to check 1 to 6. Actually, it is 6, but now it is 2. Luckily, we had to actually compare, no 6.
Yes,
And
sir.
so luckily this is already minimum, so we have updated it. ठीक है ना? चलो. So rest of things as what's your name? What's your name?
My Deepak.
So Deepak told Deepak to update. Nice. -4 1 3 4. This is 6. This is -6 5 -1 -3
-3, 5.
and this is -5. Did I leave anything?
No, sir.
Chalo then. Time is getting up. Okay, I have to finish actually. Chalo then. So for this one, tell me 0 1
0 1 2 3 4.
3. SP 5. Tell me.
1 2 6. 1 4 6.
1 2 4 6.
So
1 4 6.
1 to 6
One-
we can go.
1 to 6
4
by
6.
1
1
2
4 6.
1
1
to
4 6 and 1 2 4 6.
It will give 1.
So here I should write actually 1 to 6 we went, no? 1 to 6 via 3. Right. This is good, no? Yeah. So here how are we going in 1 to 6 we are going, no? 1
Yes,
to
sir.
6 via
4.
4.
4. Any other possibility?
1 2 6.
2 4 6.
1 to 6 via 2 and 4.
Sorry, once again. 1 to 6 via 4, that is done.
1 to
1 to
6 via 2 and 4.
1 to 6 via
2 and 4.
That will give larger value.
Yeah, but it's there. It's a
Yeah.
possibility.
Yeah. So we are actually going 1 to 6 via
2, 4.
2, 4.
2, 4. Other possibility? Can we go 2 to 6 with different path?
2 to 6 via
No,
via
sir.
4.
Via?
Yes. Via 4.
4, 6.
2 to
Via
6
4.
via 4.
Via
Via
4.
4?
2 to 6 via
It's
4.
shorter 4. It's a shorter route.
Is it
1 to 4, 6.
1? Sorry, 1 to
1 to 4, 6.
1 to 2.
Yes.
If you 1 to 2, you want to go.
Then 1 to 2 and 2 to 4, 4 to 6.
That is done in the second step. 1 to 6 is done.
Yes.
2, 4.
1, 2, 4.
So that
It
is
is
it
done.
is written. You want to go 1 to 6 via 2 and 4. So 1 to we are saying like this.
Yeah, it's
Yes,
already
yes.
Not minimum, sir. So the updation will
Yeah,
not
but
take
we
place.
we are checking and we are also going 2 to 6 via
That's it.
like this. ठीक है ना? What all things I am writing here actually. Any other possibility? Think and tell me.
No.
No.
Other is not here also. चलो कोई नहीं.
1 to 6 by 2.
Now next is what? What do you have to do? Tell me.
Update, sir.
Yes.
Update.
Chalo 1 to 6 via 4. Let me delete these things. Nice.
It will give 1.
So I should use green one. Yeah, chal, green is already. So 1 to 6 via 4. 1 to 6. 1 to 6 via 4. So what is the value you have?
1.
1.
We
1.
have 2, but it will update
1
to
to
1.
6
Yes,
we
sir.
have some value. Is there? Some value is there? 2, no?
Yes, sir.
But what is 1 is smaller than that?
Yes,
Yes,
sir.
Are we going to update?
Yes, sir.
Agree?
Yes, sir.
1 to 6 via 2 and 4. So 1 to 6 via 1. We are
Oh.
going 1 to 6
Minus 4.
via 2 and 4. Like that we are going, guys.
Yes, sir.
Hello.
No updation.
No update.
It's
No
higher.
update.
It's high. It's greater than 1, so we won't
1
update.
So it will be 1. Sorry. So we are going 1 to 6. How we are going? So first we are going 1 to 2, then 2 to 4, and then 4 to 6. ठीक है ना?
Yes.
Yes, sir.
Tell me the values. 1 plus 6 minus 3. 4. है ना?
4.
Yes, sir.
Yes.
Do we have already checked 1 to 6?
We already have
Yes,
one.
1 to 6. 1 to 6. So here no 1 to 6 we have 1. What we are getting here 4. Are we going to update?
No.
No, sir.
No.
No.
No, sir.
It will be remain same.
Yes,
Yes,
sir.
sir.
Yes,
Yes, sir.
Now 2 to 6. So next I'm telling 2 to 6. How? We are going like this.
4.
So we need to
2
update.
to 6 we
By
are
4.
3.
It will give 3.
2 to 4, 4 to 6. And what are the values we are having? 6
3.
minus 3 will be 3. 2 to what I said? 2 to 6. So 2 to 6. Do we have value? 2 to 6.
Yes, sir. 5.
Yes, sir.
I,
It is
5.
5.
We can
so
update.
we'll change. Update.
2 to 6. This is 3. Now think other possible values. Is it any other possible values? I mean possible route. I mean,
No, sir.
while using these sets, these guys. No,
No,
na?
sir.
So what we
No.
will do? We will further copy
We-
all the things and chalo then. This will be minus chalo green and red. Cancel. What is that? Recorder. Chalo. -1, -5,
-6.
-6.
This is 5 minus 1.
5 minus 1 minus 3 minus.
Oh, sorry.
Sir, 5.
Sorry,
No,
No,
sorry,
sir, it
5,
is
sir.
-1, -3, and 5.
I was checking actually. You guys are. So this is
Minus
Minus 1
minus.
minus 3 and
-3
5.
and 5.
चलो इसका 1 से -4
And
minus 5 down.
this is 1 3,
3, 4.
4.
This will be 6.
Yes.
Anything I left?
Minus
2 to 0.
2
2
to
to 0.
0 minus
Minus
5,
5.
sir.
ठीक है ना?
yes,
Yes,
sir.
sir.
What should we do now? Tell me.
Yes,
This is-
why?
SP6.
इसको मैं डिलीट कर रहा हूँ. This one also. This one.
SP6 should be the last one, right, sir?
No, we can go here to SP7 actually. Here.
Including, okay, all
Why,
7
sir?
vertices.
Yeah. So this is the actually here, no formula.
Oh,
Up to 6, we can 0, 1 to 6 like that. Is there. Chalo. So now what are the values here? Tell me then. 0 to 1, 2,
3, 4, 5.
5.
Tell me now where we have to go.
1 to 5.
1 to 6 by 205.
1 to 6 via
205.
205.
5.
So what we are doing, only one thing is possible, no other things are not possible. I think you can check now. So 5 is
Yes,
there.
sir.
ठीक है ना?
Yes, sir.
Yes, sir.
Because
Yes,
4
sir.
5 is not connected, 3 5 is not connected, 3 1 1 5 is 1 5 is connected through 2 0, है ना? So 1 5 we have from 2 to 0 we have already done from 1 to 5 in previous somewhere, no?
Yes, sir.
So only thing is we can go 1 to 6 via 2 0 5.
2, 0 and 5.
So what we are doing here, so we are going to 1 to 6,
0, it will give 0.
1 to 5.
2 to
1 to
0,
5.
2 to 5 and 5 to 6. Guys, tell me the
Yes, sir.
values now.
0.
Minus
0.
1.
One,
0.
1 minus 5.
1 minus 5 minus 1.
Minus 1 plus 5.
5.
What is this?
0.
0, sir.
So 1 to 6. 1 to 6. Have we updated anywhere?
1 to
Yes, sir. It's
Yes,
1.
sir. Now
We'll
it is
update it
1.
to 0.
Yeah, now we can change to 0.
0?
1 to
Yeah.
So we can also go from 2 to 6 via 0 and 5.
2 to 6. 2 to 6 via?
No, 6, 0 and
2
5.
to 6 via 0 and 5.
Yes, sir.
Yes, sir.
Yeah, we can do. So that's why I'm asking. No, we can also go one more you are missing. We can go 0 to 6 also via 5. This is a new one actually.
Yes, sir.
I'm telling.
Yes.
Yes, yes.
Anyway, we have updated for this one now. So we can go. Okay, so we can go 6. Sorry, we can go to 0 to 6. How? I will write yours also.
Via 5.
What did you tell?
By
How we
5.
want to go? 2 to 6.
2 to 6 via 0 and 5.
2 to 6 via
0 and 5.
0 and 5. ठीक है?
Yes.
Yes,
Any
sir.
other possibilities?
No, sir.
No, sir.
1 to 6 we can go.
Sir, 5 to
1 to 6 we have already done. ठीक है ना?
Yes.
हाँ,
Yes, sir.
sir, 5 to 6.
5 to
We have done it.
5 to 6. Where is intermediate?
No intermediate.
No enter.
We have already done. Where we have done 5 to 6? Tell me now.
SP1.
SP1 or SP0?
SP0.
SP0, sir.
0, 0, 0.
We reached SP6 and now we are coming back to SP0. चलो ठीक है, कोई नहीं. So what I was telling, चलो 1 to 6 we have already updated. 1 to 6 है ना? After comparing, ठीक है. Now 0 to 6 we have to compare via 5. So 0 to 6, what is the value?
4.
4.
We have some value 0 to 6? No, we haven't updated because if it is not updated, what is the value here? Infinity, no?
Yes,
Right.
sir.
Infinity.
Chalo. So what
So
will
we
be the
should
value here?
update.
4.
We should update, no? 0 to 6.
4. Agree?
Yes, sir.
Yes.
And 2 to 6 you are telling via 0 to 5. So 2 to 6 we are going. What is the value here?
-1.
-1.
Minus 1.
-1. So 2 to 6. 2 to 6.
We have to update.
We'll update that.
We'll update, sir.
So see, and what we are doing, so in details little bit. So we want to go how 2 to 6. How we are going? 2 to 0.
0,
5.
5.
Okay. And we are adding -5 means 2 to 0 -5, 0 to 5 -1, 5 to 6 plus 5. So it gives
Now it's -1.
-1.
-1.
in previous SP5 2 to 6 was 3, but
3.
we got -1, so we have to update here.
-1.
So for updating, I was using green, no? Oh man.
Yes, sir.
So I should follow the same. So 4. So remember, this was 4, no? 4, 0, -1.
Yes, sir.
Yes, sir.
4, 0, and -1.
-1.
Think anything other than that? Anything possible?
No, sir.
So what we have to do? We have to just copy
Yes, sir.
from the previous value.
Yes, sir.
Yes, sir.
So this is -1, -5,
Minus 6.
-6.
this is -1,
-3. -5.
5.
5.
5, sir.
So for 1, it is -4, 1,
1,
3,
3,
4.
4.
This is -1, this is 6.
6.
Okay.
Yeah.
Yep.
Tell me.
So then from this SP6, what is the interpretation what we can interpret from this? Can you summarize this one, the SP6 one?
Yeah, so SP6, we have of all the combinations. If we I and J is there, no? So if you want to read from I to J, we have used these all the possible values, meaning.
Yeah.
And among that all, whichever the minimum is there, the minimum value is written here, corresponding. I take 1, if I tell 1 to 6, 1 to 6. So we have tried all the things. 1 to 6, we have tried all the combinations. 2 and like that, we have checked. Among that, whatever the minimum came, no, up to SP6, we got the value 0. Okay? Agree, no?
No, sir. No. That I understood the process for with what we went through. But what I am asking, by looking at the SP6, let us say matrix, what exactly we can interpret? Like the 0, 1 to 6 is 0, so it is the shortest minimum path. But what exactly?
Yes. Without using the 6. Without using the 6. 0 to 5, if I'm saying, say between 0 to 5, the minimum distance is -1. Okay. From 0 to 6 is 4. 0 to 6 is minimum 4. That is the interpretation you can use. Except only that in SP6 you cannot use via 6. You can use all the via these values, but only 6 not used. Okay. Are you satisfied with, or you need something more? I mean,
No, sir. Understood.
No, sir.
No, he was doubting this. Hello?
Yes, sir.
So that is what it is represented without using 6. If I say randomly, 2 to 4, what is the value? 6. And 6 is representing what? The minimum distance between 2 to 4. This value, 2 to 4.
The minimum distance between
So, sir,
I and J, right? I comma J.
Yeah, that is the there, na? Pair of vertex.
So, sir, to confirm my understanding, so just looking at this, we can understand which vertexes have the minimum distance, minimum thing, and the maximum. Like 2 to 5 is -6, so that's the minimum.
Yeah, 2 to if you say 2 to 5, 2 to 5 is there -6.
-6.
You can also cross check in the sense.
Okay.
2 to
So like
2 to
yeah.
5.
So
Yeah.
then 3, 4, 5 has no values, and 0 also has no values up to 4, and 3, 4, 5 has no values.
These are no.
Only 1 and 2 has.
But I'm telling about when these unfilled values.
Means that is infinity, no? So it doesn't have.
That is infinity.
Yeah. So it only represents only 1 and 2 like I value, and it gives only till 5, that -5 and -6 is the minimum distance from node 1 and node 2. The rest of the nodes we will consider that is infinity, or what exactly, because the interpretation is not
Infinite. So infinity means 0 to 1 you cannot reach. 0 to 1. Sorry, 0 to 1 you cannot reach. 0 to 1 you cannot reach.
No,
you do not have direction like this, no?
No, sir. 0 to 1, 2, 3, 4. It is not there. No, all are infinity.
So that is what I'm saying. So let us say 0 to 0 is okay. Means you can understand within that one we have defined as infinity. Let us say 0 to 1. Okay. This is unfilled, means this is actually infinity, no?
Yes,
it is what it is representing. That's why I asked in previous one. So 0 to 1, can you reach in any path through any way? Like this or this, like that you can reach? No, na? Why? Because this is odd degree, you cannot go in other direction. This is also other one.
It says we cannot define the distance between the 0 and 1.
Yeah, because there is no any edge through which we can reach, because this is odd degree with respect to this one, so you cannot go in reverse direction, no? That is the meaning actually. I mean, if you say also 0 to 3, 0 to 3, can you go? No. 0 to 3, like that you cannot go in this way. Okay, we have come here 5, 6, but here it is a stoppage. This is in this direction, this one. Okay. Agree? No, I mean, still you have doubt.
No doubt. Actually, I was just this explanation I could understand clearly, but I just wanted to interpret what exactly it is giving the signal, message to the analyst.
Unfilled value. Yeah, so unfilled value, that is the meaning. Tell me.
No, so yeah, like from what I was just looking at from another angle, like only 1 and 2 has the I to J, that corresponding nodes is there, but rest of the things it does not have.
Rest of the things.
Rest of the things we don't know how much the distance will be about the path. We cannot tell anything about that. That's what infinity means.
Okay. So see how we wrote infinity here. If there is no
path, then we have
there is no any edge. I mean the directed edge. I mean, because here we are talking about directed. So you should interpret from there, no? Thus I'm trying to show in terms of distance. That is there. But how we wrote here infinity means there is no any this one. There is no any edge connection between I to J. Then you have to enter what?
Infinity.
That is what we have written everywhere, no? So here it is saying 0 to 1, there is no any edge. 0 to 1 we can, through which we can reach here. Or 1 to 3, 1 to 3 we can reach, but 3 to 1 we cannot reach. Why? 3 to 1 we cannot reach because this is reverse one. So for that, what we have enter infinity, no? This is the guy. Now somewhat clear?
Yes, sir. Yes.
Yeah. Now we have left with one last one, SP7. What to do? SP7, can you guys do, or I should write?
Sir, I don't think there will be any effect because G does, 6 does not have any.
There is no any
They
update.
don't have any outgoing edges.
Yeah, because
I think
6
0
actually,
to 6, it's 7. We
Yeah.
have 7 vertices. It's done, right?
yeah, because see, it will be same because this is, can you see this? 6 we include also, through that we cannot go anywhere, no?
Yes, sir.
It has no outgoing degree.
It will be same as
Before
SP6.
SP6.
SP6, SP7 will be same as SP6 because if we, even though we will include this one, we cannot use to odd degree because this 6 doesn't have odd degree. Oh, Anna.
Yes.
Now cross check one thing. What I was telling. So in the previous value, what was the source we had? So rest of the things, what we have to put infinity, no?
Yes.
Chalo. One thing I gave one question, no? The same one through what was the method we have? Last method, Bellman-Ford method, no? So where we have fixed one, what age we have fixed? Actually 1, no? B is actually 1. I told you to fix this one in previous one. Where is my previous question?
Yes, B.
I told to
Sir,
give
one small question. Like
the
in
values,
exam,
all things are
we will
same here.
be asked to evaluate SP23 profile like.
Sorry. No, so just a minute. I want to cross check. Means how you can cross check. So see, B. I told you to fix B. So this is respect to the distance from B to every vertices A,
Yes.
E, and that is the minimum value it should have. No. So then B to, so can you see that from B to B, obviously it is here is the definition is 0. B to A is what you have? -4. What A is representing here in this case? 1, no? I think. Where is my curve? This is
Yes,
1.
sir. Yes.
1, no? So,
Yes.
so just a minute. So this is actually what we have. Yeah, 1. So 1 to 0 will be what? It should show so 1 to 0. It should show -4. 1 to 0.
Yeah, sir.
1 to 0. Where is my thing? 1 to 0 -4.
Yes, sir.
Can you see this? 1 to 1. Obviously, it will be infinity. 1 to 2. What is the value you have? Can you cross check there?
1 to 2 is 1.
1 to 2 is 1. Means here 1, 2. This is 1 actually. So this is, let me write actually. So this is actually 0, 1, 2, 3, 4, 5, 6. The same sequence we have written there, no? If you, so 1 to 1, obviously because this is fixed one. This is the source. So 1 to 0 is 4. I'm just telling, just cross check. 1 to 2 is what? 1 is there or not?
Yes.
1 to 3 is 3. 1 to 4 is 4. 1 to 5 is -5, or 1 to 6 is 0. Can you see this? Where is my thing? Yeah. This one.
It's not the same.
It's not same, huh?
No.
What is the difference here we are having? 1 to
4 is different.
1 to 4, what we are getting here? 4. What is there?
-4.
1 to 4 is
4.
1 to 4. Where is that? 4 is 4. Why we are getting? It was, we have done for -4. What is there? What we have used here? 4 actually. There -4 was there, no? So this is 4 actually. Just minute, cross check. Which one we are checking actually? So this 4, it should come same actually. So what we are checking 1 to 4 now. 1 to 4 it is showing 4. But if we go through how we can reach to 1 to 4, just cross check here. There will be something somewhere.
So they both give the same answer.
4 is 4, sir.
1 to 4 here.
Same.
There is what?
Just copy the above one below.
1, 2. So 1, 4 is 4. Is 4, no?
Yes, sir, same.
But I
The
think
same.
we took a different one. Here we didn't pick 4 from 1 to
1
4.
to 4 is 4 actually.
And there it was -4, I think.
No,
Before
so
we
I'm
put-
checking for this one. I gave one question to you, no, this one where I have just changed to 4, no. In what I have done for there it was minus, but for the problem what I have given to you was 4, the same question. If you see that there is 4, no.
Yes, then it's the same. It's the same.
Same, no. You just cross check. It should come.
Yes, then it's the same. For the one you gave, it's the same.
Yeah. So for that I'm trying to because you should have
Yeah,
to.
for that it's the same.
So you can cross check like that also. Okay. So now I have filled each and everything, meaning if I say 4 to 6 minus 3, it can have come any pair. Means there may be n how many? It's 0, 1, 2, 3, 4. Means 4 edges can have come in between. So like I was telling 4 to 6, I want to 4 to 6. I want to check in between many. K can have many numbers, no? Among that 4 to 6, it can come 4 to 6. With this graph, I cannot from this one we can interpret that in between something will come that, and among that whatever the minimum value we have to write here. That is what we are doing in the every application, no? Wherever we are finding SP5, SP6 like that, no? For particular graph SP from 4 to 6, 4 to 6, we cannot come from anywhere. No, only this is the possible. 4 to 6 minus 3. That's why it is minus 3. Okay. Did you understand this one?
Yes, sir.
Then
Yes.
if you understand, then do for -4 then. You try to do by yourself and cross check with the what. I'm giving you one question. So whatever it is for here, na, or do it for this guy. For where is my previous? Yeah, Bellman-Ford. This is the -4, na. Do for this one what?
Floyd-Warshall.
Floyd-Warshall method, and use try to cross check with these values. Okay. How we will? This is the
Then can we use pencil and then erase and do it every time?
Sorry.
Can we use pencil in exams so that it's the same paper we can use again and again?
I don't think so. They will give you this much to do calculation. I don't know. Means they will frame in such a way that like it will take less time. Okay.
Last weeks are told 5 edges or some 5 vertices or something.
So it will be good. Like rough pages, it will be given. No, so you can use your pencil. What is there? It's good that if you use the pencil.
Sir, a question will be come like find the shortest path, or it will be telling that use this method particularly and find the shortest path.
No, you are if question is there is no any negative, you can use the simple just if it is negative is there, you can use this kind of
Bellman-Ford.
yeah. If you are supposed to find if some edges are fixed, if you want to have to find the pair in between any pair, you can use this one, Floyd-Warshall, Bellman. So this is the difference. So clearly this is the you can understand which method you should use. Depends on the how the graph.
Sir, my question was that only it will be asking that okay, find the shortest path, and that depends upon if it has negative value, so then we should choose one, or if it has positive value, then we can choose.
Yes.
Okay.
I don't think so. That much too much subjective question will be asked. I don't think so because it will take too much time. We are not testing you to your time, testing your skills in the short time because you are not having pen and paper examination. It's just like MCQ. Okay, na?
Okay, sir.
And maybe you can post now. So it's 6:30. Maybe a studio will be closed. So whatever the question you are having is related to the. You can post on the discourse or discussion forum. And if you want this one, do you want this? Page. This slides.
Yes, sir. Yes, sir.
Yes, sir.
All pages last
Yes,
yesterday's
please
class
upload
also.
the PDF.
Sir told today.
Actually, two more algorithms left, Prim's and Crystal's algorithms.
Take whatever is remaining. So that's why we are not explaining all the things, because time, you can understand that how time now it's a 6:30 itself. So next, Dijastra and remaining methods, whatever the spanning tree, something is there, no? So that will be explained in solve in instructor session. The main focus on that one. Okay, na?
Yes, sir.
All the question you try to put, and I will share this one with Srikant, and he will share to you guys. Okay, na?
Thank you.
Okay, sir. Okay, sir. Thank you so much.
When are you going to take CT session?
CT, sir.
Yeah, I will take definitely. Maybe GMIT on demand session is required
Yes, sir.
Tomorrow.
Yes, sir.
tomorrow.
Yes.
Tomorrow start is
Please, tomorrow, because we have a submission deadline, so it would make things
For
clear.
what? Which one?
Tomorrow we have
2
11.
weeks,
10
sir.
and 11. 10 and 11.
So tomorrow, I don't. Omkar had
CT.
taken some session. No, I think in 10 and 11, I'm not too much confident, because my background is not that side. So I can only talk about the lectures, means whatever sir has explained. That the extra thing I don't know, means too much in that. So Omkar is the right person. He will try to take if he get the time. I will request him to take some session. Okay, na?
Okay, sir. Then till 9 you will take, sir.
Yeah,
Sir,
yeah.
said take the session.
Sorry.
Sir, at least for 1 hour you will take, sir.
Which one? Which one? Sorry. Hello. Hello.
Yes, sir.
Yeah,
Yes,
yeah.
sir.
What he said.
एक्चुअली ओंकार तो नोटपैड खोलने के लिए थोड़ा हेजिटेट करता है. आप लोग होगा तो you and Rahul, you will open the notepad and you will explain clearly. That's what we need you guys.
Omkar sir is
Especially
considering us, and we are in high level.
Yeah, he's just, his level is very high.
Yeah, so he
Yes,
is thinking from his
Sir,
level.
he feels that opening notepad and explaining is simply time waste. He assumes like that.
Okay, okay, okay. Okay, so
Over the head it is going, sir.
okay, okay. Chalo then, so I'm stopping this session. ठीक है, we'll meet it. हाँ,
So please share this PDF on resource from instructor session.
I will share this PDF to Srikant, and he will share with you guys. ठीक है ना?
Okay, sir.
Okay.
Thank you, sir.
Thank you.
Hello, sir.
Thank you so much.
Thank you, sir.
Thank you.
Thank you very much, sir.
Thank you, sir.
Deepak sir, can you hear me?
No, sir was left.
I was on mute.
Deepak sir left.